Hi everyone, today we are going to discuss about the topic binary search. As we all know, we have learned what is a linear search earlier. In the linear search, I told that we don't need a particular array to be sorted and unsorted. It works on all types of arrays. But in the binary search, it only works on the sorted array. Okay, that is, you need to have an array which is in ascending order always. It doesn't work on unsorted array. That is what you have to remember. So let me consider here an array with 4 elements, that is 12, 21, 36 and 40. Array index always starts with 0. Number of elements here is 4. Now, how can I implement binary search is nothing but for this you have to, as the name suggests, binary search. Here what you will be doing, whatever the array you have, you will be dividing into different parts and then you will be checking the whatever the element you need to search for. Okay. So here, how can I divide this array into 2 parts? For that you need help of 3 variables. One is low, high and mid. Okay. Now low will be pointing to this first index, that is beginning index value, and high will be pointing to the last index, that is nothing but size minus 1. So here it is nothing but high equals to 3, that's why I can say it as high equals to n minus 1. Okay. Now how can I calculate this mid element? Mid element can be calculated with the help of this formula, low plus high by 2. So here you will be considering the floor value of this. Okay, low plus high by 2. So how can I calculate the mid element here? So what is the low value here? It is 0. What is the high value here? 3. 3 by 2. Okay, it will be equals to 1.5, that equals to 1. We will be considering the integer part, not the decimal part. Okay. Now the mid element will be this thing. Mid will be pointing to the first index and the element is mid element. Mid element is 21. Okay. Now what we have to see here is how with the help of mid element, how can you divide an array? So when the element here I am going to search, let's suppose it is 36. I need to compare the mid element and the what are the data I am going to search for, whether they are equal or lesser than or greater than. There are 3 cases here, whether the mid element is less than the data whatever you search, or you can call it as key also, or mid element is greater than the key element, or it's equals to the key element. So when it is equals to the key element, you will stop the search. Okay, this is a successful search. So here, if you consider a of mid is 21. 21 is less than 36. What does this indicate? The mid element, this will indicate that what are the element you are searching for is on the right side of the mid element. So you will be considering this array, only this part. Okay. Let me explain this clearly. So array I have here is 12, 21, 36 and 40. Okay. 0, 1, 2, 3. N equals to 4. Okay. We need how many variables here? Low, high and mid value also you need it, right? And here you will be having the whatever the mid index. This is index. Mid will be pointing some index value, and here you are going to calculate what's the value present in that particular index. Okay. Now initially low is 0, high will be pointing to this. That is what I told earlier. So high is 3. So here what I have to do? I have to calculate the mid. So I am saying 0 plus 3 by 2. It will be floor of 1.5. So it will be 1. So a of mid. This is the middle element. Okay. A of 1 is 21. Now the element key what I am going to search is nothing but 36, right? I want to search this particular element 36. So here I will just compare this mid element, whether it is lesser than 36, greater than 36 or equals to 36. Okay. But this condition has been met, right? 21 is lesser than 36. What does this indicates? That 36 is present on the right side of the mid element. Okay. So what I will do here now is I will just consider this part. This array. The left part is not considered of the mid element, because you know that what are the element you are going to search is greater than the mid element. So that will be present on the right part of the array. This mid element, okay, right array. So what I will be considering here is I will just consider this part, this array, 36 and 40. What are the elements here? Index values 2 and 3. Okay, index values are 2 and 3. Now here you can see that the high value is always 3 only. The high value didn't change. But if you see here, the low value is not 0 now. Low value is 2. Now how can I represent this low value? Can I say this low value as mid plus 1? Yes, I can say, because mid is 1 here. Mid, the index is 1. So I can say that low value is 2. So I will say low equals to mid plus 1. Okay. That is what I am going to write here. Low is 2 now. 2. High is 3. Now again I need to calculate the middle element. So 3 plus 2 by 2. That is 5 by 2. That equals to 2. Okay, 2.5, and floor value of 2.5 is nothing but 2. Now what I have to do? Now this has become the middle element. This has become my mid and this has become my low also. Okay, 2 is my low and mid also. So now here I will be writing, what is my A of mid? A of mid equals to 36. 36 is equals to key. So here I will give the user that the element has been found and you have reached a successful